Hey everyone, it is time for another recitation. This time we're going to be going over the topics from WebDB 1, which is going to be our SQL queries, and using Knex as our query builder. I'm going to be trying something a little bit different today. I am not going to be going over the afternoon project from yesterday. I'm going to be going over a similar project of my own devising, where hopefully we're going to touch on many of the same topics, and we're going to discuss those and learn more about those and all of that without revealing, you know, solution code, copy and pastable answers for the project. And my goal with this is some of you may have noticed that the previous recitation videos that I made have become private. I was made aware of a number of students who were not using those videos constructively in other cohorts, and so I made the personal decision to make those videos private for the time being until it's possible there may be some way to mitigate that issue. I'm hoping today that people will still enjoy a video on similar topics without it being necessarily identical. But as always, I really appreciate any of your feedback, so please feel free to message me on Slack or whatever other platform you have my contact info on to let me know what you thought and any other feedback that you have. Let's see. All right, so today we're going to be doing WebDB Recitation 1, the link for which is in the After Party channel and is going to be in the description of this video as well. So what we're looking at is a very similar project. We have a number of queries that we want to accomplish using just straight up raw SQL. And then I also have set up for us to build some CRUD operations on a resource, and then also handle a similar stretch challenge with the query parameters in order to modify the way our data is returned on our get, which is going to be pretty fun. So for this project, included is the database already, like the other ones, and we're going to be running SQL queries directly against that. And I think that's cool. I really like the web interface that we had on the project, because that's a great way to get started and experimenting with this. But I want to show you some of the cool powers that we get when we use the command line SQLite interface. Because one, I like the command line. Two, we can do some pretty neat things with this. So I already have pulled up here a terminal inside of my project directory. We have all of our stuff in here. I'm going to cd into data, and this is where I have my dev.sqlite3. That's my database. If I want to open this database with SQLite to run queries against it, I can use the command line SQLite3 and then give it the name of the database that I would like it to open. Now I hit enter, and here we are. We're at the prompt, and we can start writing SQL. So there are some useful meta commands that I want to go over. One is .tables. This will list all of the tables within this database, which is a database kind of outlining a book review website. This is from my build week. So we have books have authors, books have subjects and publishers, and we also have users, then they can leave reviews. And we won't be doing everything here today, but I'm probably going to use this throughout the remainder of the week. And I see someone raise their hand. Do we have a question?
Yeah, Henry, so the SQLite 3, is it something you have to install as a CLI in
Uh,
order to work?
if you have SQLite installed on your computer, the SQLite 3 command should work. I believe it comes pre-installed on Macs. I see Elijah is also having issues with it running. Are you all using Windows where you're having trouble getting that to work?
Yes, I'm using Windows.
Okay. Does just plain SQLite without the 3 on the end do it? I know it won't for me, but
Nope, that didn't work either.
nope. Okay, so then that could be a path issue that I would have to look into. Did you install SQLite 3 specifically when setting up your projects for the week?
Yeah, I mean, I downloaded the SQLite Studio, and then I'm using SQLite when I'm playing around with these projects.
Yeah, but what about like what about this? Like actually downloading the binary and installing that. We can look in that later. I don't want to spend too much time in the video on this. You should also be able to, if you do have SQLite Studio installed or SQL Studio or whatever, you should be able to open it in that and run commands against it. Because our SQL isn't going to change. I just kind of want to show off what this command line tool can do. So that would be my recommendation for now. All right. So for those of you able to follow along on the command line, here's some cool things we can do. The .tables command is going to show us all the tables that we have. We can use the .schema command to view this schema for a specific table. Now this isn't super readable. We can run this command with -- indent in order to have it format it a bit more nicely, so we can see books have an ID, a title, an ISBN, and so on and so forth, and we can see their data types and any other interesting information about that column. And we can run queries against this. So I want to select title from books. Now, you're going to do this and you're going to hit enter and you're going to get this extended prompt down here at the bottom. And what that is telling you is you haven't ended your line yet. So you have to end your commands with a semicolon in order for this command line interface to stop parsing them and actually run what you asked it to. So here we go. We get all of the titles of our books. And we can also get multiple things. Again, this is just normal SQL, so I want to get the title and the year from the books, and now we can see those all show up. This isn't super readable. We have more options to configure this. One, we can say headers on in order to get column names at the top. See, now we have title and year here. We can also change the mode we display this data to column. And now when I run this command, these will be outputted in columns. The width is constrained. We can manage that as well. And really, there is a whole lot of stuff we can do in this command line shell for SQLite. And there's a lot of things here. I briefly want to discuss appropriate use cases for SQLite, right? Because I know some of you are interested in, like, why are we using Postgres when we deploy to Heroku? What is Postgres? What are the differences? Well, SQLite is an interesting database because it manages all your data in a single file, and it's not built like other database management servers where the goal is for it to run as a server and have tons of different connections open to it and manage concurrency and all of these other desirable things really well. What SQLite is it builds itself as an alternative to fopen, which is a command to open a file on your computer, right? SQLite is an embedded database. It's really good for embedded devices, right? A device that needs to have a database on it rather than a database being on the server. You can also use it as an alternative to serialized data formats. So we can store, data in JSON files that we can parse and read into our JavaScript programs, or we can store them as SQLite databases because you're going to see there's a lot of advantages to being able to use this format. It also works well for medium traffic websites. And what they mean by that is 100,000 hits per day. That's fine on SQLite. Relational databases scale very well. In fact, SQLite scales slightly less well than other databases. The maximum file size they have listed somewhere in here, it's 140 terabytes. So if you need a database that's going to be larger than 140 terabytes, maybe not SQLite. But SQLite is kind of like a Swiss Army knife tool. You can also have it import CSV files, export stuff to Excel. We can change our output format to various things. Like we can change the output format to HTML. And now when I run this query, I get HTML formatted output. SQLite is a very cool tool in order for us to investigate and process data outside of it just being a really convenient database environment to develop our programs with. So SQLite is neat. I would definitely recommend checking this out when you get the time, and I clicked the wrong button. Okay, so I'm going to change my mode back to column. I'm also going to set the widths of various columns to 0, which is going to have them auto scale to the size of the first value in that column. So we see classical mechanics fit, but the other ones get cut off, and that's fine. That doesn't bother me too much. All right, so now I want to run some queries against this. So the first query that it asked me to do is to find all books with a publisher ID of 2. So we can again look at the schema -- indent of the books table to view everything that's in there. We have another command to view this in perhaps a slightly more friendly format, which I'm going to have to look up real fast. Pragma table info. So Pragma table info books, and that will also show me the information about my books. So every book has different information: title, ISBN, covers, descriptions, edition, years, and publisher ID. So I want to select all the books. I'm just going to get the title of each book from books where the publisher ID is 2. And I have to end my command with a semicolon. And there we go. There are all of my books that were published by publisher 2, whoever they are. Do we have any questions with that command?
So is equivalent to equals in SQL?
Yes. Yep. You're going to find different database systems have slightly different words for things, and support for stuff is and equality here are going to be essentially the same. So I just used is. We can also see I was not strict about capitalization. You'll often see SQL commands written with all of the SQL keywords capitalized. This isn't strictly enforced by SQLite as it's parsing these. It's really more of a helpful tool for us to see what are commands and then what are things that I want, because I can select a column called select from books, and having the mix of uppercase and lowercase helps determine, okay, this select is a command select and this select is a column name select. All right, so there is all of our books with a publisher ID of 2. These will also be going into the repo. I actually did them yesterday, so don't worry. Those will all be in there as well. All right, so the next thing we want to do is we want to find the title and the cover URL of the book with an ID of 1. So we're going to do select title. If we want to select another column, we separate them with a comma. So that's going to be the cover URL of the book with the ID of 1. So we want to perform this selection from books, right? We always perform our selection against the entire table that we're looking for, and then we qualify what exactly are the things we want from there. So I want to select the title and cover URL from all of my books, but I want to filter them with a where the ID is equal to 1. And there we go. We find that this book is Classical Mechanics, and here is the cover. And I'm going to talk more about that later because I like this book. Now notice I did not specify the ID over here in terms of the columns I'm actually selecting, but I can still use it in my where. And that's because SQL is aware of the columns within the database that I'm querying from, and it's allowed to go and find that ID, even though I'm not explicitly referencing it inside of my select. So, any questions with this one? SQLite's strict about semicolons. I don't know when it is being fed actual queries, if it's strict about semicolons. In the command line interface, yes, because oftentimes it can be easier to input commands on multiple lines, and so it just keeps reading different lines as being part of the same command until we give it a semicolon. So I believe that's more of a quirk of this command line tool than it is the actual database parser, but could be wrong. Knex also handles that for us, so we're not going to be writing raw SQL scripts against SQLite. Okay, so now I want to find the title and year of the oldest 3 books. So I can select, try to be better about this, select the title and the year from my books, and so that will give me the title and the year of all my books. But I want to find the books in order of their age. So we can use our order by. I want to order by the year, and I also want that to be ascending. I want to start with the oldest books and have that year count up. So ASC for ascending, and there we go. Now we start with Introduction to Statistical Inference in 1987, and we go forward. If I just want to get some of these, we can use limit. And that will accept a number of how many rows that we want to limit our result to. And so if I do limit 3, I'm just going to get the oldest 3 books. Any questions on this one? All right, so next up we have find all reviews for books with IDs 3, 4, and 5. So there's a bunch of ways of handling this. So we want to select, let's just use star from reviews, and let's see what's up with that table. So here are our reviews. We can see here the schema is not as complicated. Each review has an ID, a rating, a comment, and then the ID for the book that the review references and the user who left the review. So I want to find all the reviews from users or for books with the IDs 3, 4, and 5. So if I wanted to find the reviews just for the book with the ID of 3, that's easy enough, right? That's going to be where, in this case, book underscore ID is or equals 3. So there's all of our reviews for the book ID 3. If I want to include multiple books, I can use OR, right? This is just like our logical OR operator in JavaScript. I can run multiple equalities in here. I can also check if the book ID is equal to 4 or the book ID is equal to 5. And there we go. Now we get reviews where we have book IDs of 3, 4, and 5. Now I want to show you a very common gotcha that has straight up destroyed websites in production databases before, which is you're going to be very, very tempted to write this command where book ID is equal to 3 or 4 or 5, right? That looks good. We get all of the reviews when we run that command. And does anyone know why? Very subtle. Very subtle. So, what we're doing here, right? This is going to be, oh, I didn't like that. This is going to be roughly the same as if we were in JavaScript doing an if statement, and then we're checking to see if some variable is equal to 3 or 4 or 5. This would always evaluate to true, because we would check the equality here. We would check to see if sumVar is equal to 3, or we would check to see if 4 was true, right? We're not performing an equality against 4. We're just checking to see if the value 4 is true, which it always is, right? In JavaScript, any number that isn't 0 is truthy. And that's going to be the same in our SQL database, right? What we're actually checking to see is we're checking to see if the value 4 is true, which it is. So this is going to run against all of the rows in our database, which here, oopsie daisy, we got to fix it. That's fine. But what if I'd been trying to delete or update? Suddenly I've accidentally modified all the rows in this database or deleted all the rows within this database, which is a thing that happens. And there's ways of fixing this. One, be better at writing SQL, but two, always test your code against a testing database before you run it into production. And there's also ways to see how this is going to execute before it actually runs. But we have to be careful when doing these ORs that we're checking if book ID is equal to each of these at each point in time. Now we could also do this with some kind of range. Another way to do this is with the in keyword, where we can check and see if the book is in this essentially array of 3, 4, and 5. Right? And this will also work. It will check to see if book ID is in the selection of things. And there's some slight performance differences between the two. I'd recommend you research it if you're curious about it. But in SQL, we often have many ways of expressing what we want because SQL is a programming language, right? And we have the options to program as we see fit. So any questions on that one? Okay, great. So now we're going to insert a row here. I want to add a review for book 1 from user 8 with a rating of 3 and a comment of okay. So let's do that. Here, the way we do our insert command is with the insert keyword, and we want to insert into the table reviews, and then we specify in a list the columns that we're going to be inserting data into. So this is going to be the book ID, the user ID, the rating, and the comment. And then I specify the values that I want to go into those columns. So it is going to be 1 for the book ID, 8 for the user ID. Our rating is going to be 3, and then our comment is going to be the string okay. Oops, and I hit enter too early. That's fine, I can just finish this line. There we go. So now I can select star from reviews, and we see that I have this right in here. Now, I think my OK actually picked up that new line, which is pretty funny, but don't worry. Our next challenge is to change our review so that it is much kinder to that book. So if I want to update those values, I'm going to be using the update query, or the update command. I want to update the table reviews, and I want to set the various fields to be different values. So I want to set the comment to be amazing cover, and I separate each of the columns that I want to set with a comma. I also want to set the rating to be 5. And I need to specify which rows that I want to perform this update with. So after doing my select, I know that this is the row with the ID of 19, but as we saw when I ran my insert, I didn't immediately get that information back. So what can we do if I don't know this ID of 19? Well, I can use any other qualifications that I want to determine which rows that this update should run against. So I know that this review is going to be from the user with the ID of 8, and I know it's going to be against the book with an ID of 1. So I can use that as the clause in my where the user ID is 8, and, right, as the corollary to our OR, we also have access to the and the book ID is 1. So there we go. We've now updated our review, and I can select all my reviews, and we see that that one has updated. It's no longer weirdly formatted, though it is cut off, and we have a good rating for it. While I do my awkward pause asking for questions on this one, I want to show you the cover of this book, because I'm in control of your time right now. So do we have any questions?
Yeah, is the set command used with the update only?
Yes.
Okay.
We use the values with insert, and we can use set with update. So this is the book in question. It's Classical Mechanics by John Taylor. It's a book about physics. Right? It's classical mechanics like Newtonian and Lagrangian and Hamiltonian mechanics. But the cover is of a classical mechanic. It's an old car. It's very clever. This is the height of humor within the field of physics. All right. Any other questions on this one? On updating and whatnot? Okay, so now here are a couple of our kind of stretch problems where we get a bit more complicated about the SQL queries and the tools that we're using. So I want to know how many different years books were published in, as well as how many books were published in each year. So I'm going to do this second part first. So if I select, let's get the title and years from my books. Title and year for my books. We see we have a bunch of different books and they're published in a bunch of different years. And so I want to know how many books are published in each year. So I may know that we have access to various functions within SQL, like length and count, that will perform math on our various rows and values and give us the output of that. So what I can hypothetically do is select the title and the year for my book, and then also count the year, and then select this from books. And what we get back is a single row. It's classical mechanics and a year of 2005 and a count of our year 15. So what this did is it just counted the number of rows that have a year in them and then gave us the value, and it turns out we have 15 books. That's not quite what I want. I want to count the number of books that occur within each year. And what we can do is we can tell SQL to group our data into different sets, and then we want to count inside of that set. So what I'm going to do is I'm going to select the year and then count those years. And I want to group my data by, we use the group by command here, and I want to group them by the year. And so this will essentially chunk them into different sets where the year is the same between each book. And so now when I run this command, we can see that there's one book published in 1987, one in 1995, two in 2010, two in 2017, and so on. So this will structure our data in such a way that count will apply on each one of these groups. And that's really cool. This is where we start unlocking the power of like, oh, SQL is very good for some things that JavaScript, this would be a lot more difficult to express in JavaScript. I like SQL, and this is fun. So do we have questions with this?
Yeah. Regarding the group by, I think correct me if I'm wrong, but group by is used typically when you have when you're selecting the count of one of the columns, right?
So group by is generally used with what we call aggregate functions within SQL. So an aggregate function is something like count, or we'll see in one of the further challenges, average. So these are commands, these are functions that run over multiple rows of data. They aggregate them essentially into a single row. We saw with here, when we just counted the years, we got a single row that counted all the years. It counted all the rows essentially. And so we aggregated multiple rows into a single row. And what group by does is it sets the number of rows that we want to aggregate at each point in time. So here I want to aggregate the columns, and really I could have counted anything. It's not important that I'm counting the year here. I'm just basically counting the number of rows that are in each grouping where we separate them by the year that they have. So we usually use group by in conjunction with aggregation functions. Count, average, min, max. There's even in PostgreSQL some functions that will aggregate things into arrays and JSON objects for you, which are pretty cool, and I'll try to do a video on in the future. All right. So any other questions about this?
So yeah, so if you were just to select year and another column without an aggregate function, this would generate an error, right?
So let's see what happened. No error. No error. What this does is it groups our data by the years. So we see when I remove the group by years, we get more books, right? What we find here is we actually get just a unique value, one for each year. We don't have any repeats, whereas in here we get repeats. Because this is, again, this group by is attempting to aggregate our data into sets of rows, and so we end up only getting those groupings. But we're not really doing anything with them, so we just see essentially unique values here. Now, we don't want to use group by to perform uniqueness-based stuff. I'll talk about that in the other half of this question. But we don't necessarily need to use this with an aggregate function, but it doesn't usually provide us a significant amount of value without an aggregate function. So, there we go. I want to show one other thing with this, is we see the column name for this shows up as count year. And if we're doing this with Knex, that's going to be the key for that column, and that's not great. We can rename this using as. So I'm going to call this num books. And now we see in this query we have the year and the number of books published within that year. And what's double cool about renaming with as is that we can now reference this column name in other parts of our query. So for example, if I now want to order these by their number of books descending, I can do that. And so I've now ordered these by the number of books in descending order, so we see that 2016 is the year that had the most books published in it. So, renaming columns with as. Pretty cool. You don't have to do this with functional columns like count. You can also just rename existing columns. Like I could rename year to year published if I so wanted to. All right, cool. Any final questions on this one? All right. We'll just do these last couple because I want to get to some of our CRUD endpoints. I also want to find out the different years the books were published in. And so what I can do is if I select the years from books, we see all of these different years. And I capitalize this weird. If I use the distinct keyword, we now only see the distinct years. We don't get repeats. We get the unique years. And this is what we want instead of using group by in order to essentially filter out non-unique values here. If I want to count these, then perhaps unintuitively, we count distinct year. We put the count outside of distinct year. And there we go. We now get the fact that we have 10 different years in which books were published in. That's pretty neat. Any questions on this one? Okay. So then, what is the average review of?
Sorry, I did have a question on the distinct.
Yep.
So if you want to like select a distinct, one distinct value, but you don't want it distinct from the other column, how would you do that?
So this is one of these things where you know, you can play around with these things and see what happens. So what happens if I do distinct year and title? Well, how many rows did I get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I get more than 10, right? And we can check and see, oh, yep, we do have repeats in here. We have two 2016s. So this didn't work in the way that I necessarily expected. We didn't get the distinct years and then only the titles corresponding to those distinct years, because, like, how would that work? We want to get the distinct years, and there's going to be a different title within each row, so which title ultimately gets chosen? So if you had an example of the kind of query and the result that you wanted from that, we could play around with that and see if that happens. But I'm not sure exactly what you would want to happen in this case.
Right, I see what you mean.
Mhm.
Okay, I would have to come up with a credible example.
Yeah.
Right. Okay.
All right. And so one of the really cool things about SQL is that we generally want to avoid putting derived data into the database, right? So when I get all of my reviews, we see that we have a bunch of different reviews for a bunch of different books. And if I were making a website that allowed us to review books, it might be very useful for me to be able to see the average rating that a book has. And what I could do is, in my JavaScript, every time a new review comes in, I could get the average number of reviews out of my database, and I could calculate that review into the average, and I could store that back into the database, but we don't want to do that. SQL is designed such that we can run aggregate functions on our data, and they happen very, very quickly. It's very good at doing this kind of math on all of our different rows for us. So we wouldn't actually store the average review for each book inside of our database. We would just write that as part of the query when we went and got our book. So if I want to get the average review for each book, I want to select, let's get the book ID. And then I want to use the average function on the rating. And I want to do this in the reviews. And I want to group by. Whenever we use this aggregate function, we need to say group by. We need to say, all right, what do I want to calculate the average for? I want to calculate it for each different book ID. And now what we see is I have each book ID and then its average rating for each one of those. And this happens very efficiently, right? It's fine that I don't have this data stored. It's fine for me to recalculate this on each request, because SQL really good at doing this, right? A lot of these things, the more we can let our SQL server do, the better, because SQL can often do things much faster than JavaScript can. And databases like Postgres can easily scale to millions upon millions of rows without really experiencing a slowdown. So SQL is good at this. And note, I can do my same renaming here. And this would allow me to, if I were using Knex, to have a key in my object show up called average rating, right, and have this value in, and the person consuming my API would have no idea that we actually calculated this data on the fly for them, and that it's not stored inside of our database. So aggregate functions are really cool, right? And we can use this to do all kinds of interesting analysis of our data, right? Like, what if I wanted to find the average rating that a user left on a book? You know, all I have is this basic data inside of my my database, right? But with just a small change to this query, I can see the average rating each user gave, right? And so this might allow me to identify a user that's just going through and like review bombing all the books, and their average rating is like 0. Right? We can do interesting analysis on our data with SQL. SQL is very cool with this, and there's lots of interesting functions like average and other aggregate functions and more complicated things we can do. For our last one, which book has the longest description? Right? We can use more of our queries. So I want to select, let's get the title and the description from our books. Some of these descriptions very, very, very long, right? I just want to find the book that has the longest description. So what I can do is I can use my order by clause, and I want to order it by the length, this should be capital, of the description. And this will actually count the number of characters within that text for the descriptions. And I want to have this descent. And there we go. Turns out the little schemer has the longest description. Right? And I don't have to include this inside of my select. I'm allowed to do this strictly within my order by. If I want to see how long that is, I can do length of the description. I can't really type description as description length, and then I can order this by the description length. And there we go. The little schemer's description length is apparently 1,326 characters. Neat. Very easy to do that. Very quick for that to happen. All right. Any questions on this? Oh, and if I wanted to get just this one, I'd do limit 1. And that would be roughly equivalent to us doing our kind of dot first. But you see now why Knex always returns an array, right? When we do our where or our order by or whatever, there's no guarantee that we're going to get a single thing. Only we know that we expect a single thing. So, okay. Any questions with this? All right. Well, then I am going to exit this SQLite command line thing, which we can do by pressing Control-D, not Control-C. We do Control-D to exit prompts. And I'm going to go over to the actual project. And here are all the queries we just did. Those will be pushed up to the repo at the end. So with our project here, I already have a Knex file configured to connect to our database. I have migrations and seeds already set up. You can play around with those if you'd like based on what you know from today. I also have an index file that is set up to scaffold my server. So I'm going to get our server running by doing yarn server, and it's going to listen on port 5000. Then inside of my data directory, I also have our db.js set up already that imports our Knex config and exports our database connection based on that. So what's left for me to do is write my routes and write my model. So I'm going to create a directory called reviews. And in here, it already had cached some of the experimenting I was doing yesterday. I'm going to create a file called reviews router.js, and this already has everything that I did cached in it. And so we're going to do our normal things in order to create this router. We are going to require express. I'm going to declare my router with express.router. I'm going to export my router with module.export of my router. And then let's just do router.get on /rec and res and res.status 200. We'll just end that just so we can test and see if that's working. Now I'm going to move back into my index.js, and I'm going to import my router as reviews router, right? And notice this is a const, right? This is a variable. I can call this whatever I want, even though what we're exporting and requiring on the right-hand side is called router. Doesn't matter. That export isn't actually aware of that name at all, right? Variables, call them whatever we want. They're banana names. So I'm going to go into, did I do this in data? Okay. No, I didn't. Good. Okay. So I'm going to go into reviews and import my reviews router. And then after I apply my JSON middleware, I'm going to do server.use/reviews, and then I'm going to use my reviews router. There we go. So let's check and see that this is working inside of Insomnia. So I'm going to do localhost 5000/reviews. And there we go. We're getting our 200 response back that we had set up right here. So this is our router. Now, I can import my database directly into here and start writing my commands to interact with my database to get and modify various data we're in. But it's generally a good idea to set up our projects like they've been modeled to us for this past week, which is to have two separate files. One for the router, right, that handles the network, the request response side of things, and then one often called the model, which contains the model of database interactions that we have for that resource. One, names help, right? Writing those into functions with various names is a form of documentation, right? It makes our code more readable when I can see that I'm performing something like reviews.get here rather than something like db reviews or maybe get by ID, and this suddenly becomes, where ID. Which one of these lines would you rather read as a developer? Probably this one, right? Probably this one. So function names help. Delineating responsibilities help. One, because we're allowed to essentially treat this endpoint as being somewhat unaware of the realities of the database existing, right? It's just calling this function that returns a promise that either contains the data or throws an error, right? We don't have to know that there's a database here. Another benefit is sometimes our resources need to interact with each other, right? If we want our books to have an endpoint that's going to go and get all the reviews for that book, I don't want to rewrite the information here, right? I want to use what I've already written inside of my reviews model. So I like separating these. I think the goal yesterday was to allow you to write them in the same file in order for it to be a bit easier to reason about, but I'm going to split them out here. So I am going to go into my reviews directory, and I'm going to create a file called reviews model. And we've seen during various days these be named kebabbed case, right, with the dash in between them, or cameled case with the capital letter. In file names, we don't have the same strict requirement that we do in JavaScript with camel casing. It doesn't matter which one you use, just be consistent, right? That's the important bit, is being consistent. So I'm going to delete everything that I had done yesterday. We're going to start out by requiring our database. So I'm going to require the DB. To do that, I'm going to have to go up a level into data and then grab my db.js. And then I'm going to set up my module.exports. And what I'm going to do is I'm actually going to export an object here. And as I define each function, I'm going to place them within the exports. And that's going to allow me to do the thing where I do like reviews.get. Right? And this is one of the ways we can export multiple items from within a single file. So I'm going to write my get function. So I'm going to call it function.get. You could also call this find or whatever. It doesn't really matter. These are function names. You're in charge. And what we're going to do is we're going to run db reviews. Easy. So easy. You're going to find most of these model functions are going to be pretty stock standard things that you're really only going to have to figure out how to write once. And then I wouldn't recommend them you copy and pasting them between projects, but it's fine to go and reference old code and be like, yep, that's how you do that one. So now within my router, I can require the model, and oftentimes we'll see this listed as the capital letter version of the resource that we're using. You can call that whatever you want. I'm going to call it capital reviews here. And then I am going to get my reviews model.js file. And now I can do reviews.get. And then my standard.then, getting the reviews. And then I will send back my status, where the JSON payload is the reviews. Otherwise, I'm going to .catch, get the error, console log the error, and res.status 500.json error fetching reviews. I also had a question about this earlier. What if we want to tell the user what actually went wrong within our database? Well, this error object, it's a JavaScript class, and it has various fields and properties we can interact with. One of them is called message. So if we wanted to, we could send them back the error.message. This is very similar to when we were writing Axios requests in React, how if we wanted to access the request object of the failed request, we would do error.response, right? Here we can do error.message and get this message. It's not always a good idea to return this without us looking at it first, because it might contain some information about our database or something that we don't want the user to see. And also, like, seeing the raw error message, if, you know, this is a client intended to be consumed by, you know, random developers, not developers within our company, we might not want to put it in there. But it can help you debug things during build week if you know, your front end people can just straight up tell you, yeah, this is the error message we're getting back. It's saying something about unique constraint failed, and you can be like, oh yeah, there's already a book with that title. Or, you know, you can also parse this error message, right? We could see if, you know, error.message, you know, includes some text or contains. I can never remember the name of this thing, and we can give back more detailed error message, is depending on what actually triggered that error. So error handling, it's fun, it's complicated, it makes your code look weird, but that's what we got to do. All right, any questions on this?
Yeah, so regarding the error.message and error.response, what documentation do we look at to see what's available to these things that are returned?
You can usually look at the documentation of the code that is throwing the error. So you could look up the Knex documentation and see how it throws errors, or the Axios documentation. You can also, when you console log the errors, it'll tell you. It'll show you additional fields that they have. When we get to post or put, I can do it wrong, and we can see what shows up in the console log, and it will have different fields that you're allowed to go and grab. Message is just the default part of the JavaScript error, and you can read on the MDN page about this. Errors by default have 3 fields: message, file name, and line number. And so we can do, right, if we search message, we'll find error.prototype.message. That's just the error message. These are our standard properties that we got in here. Oh, and it looks like Mozilla and Microsoft have different things. We also have different methods. Ooh, we could also do error.toString, and that would include information, not just the message, you know, other information contained therein. So errors are a normal part of JavaScript that we should learn and love. All right. So let's write some of our other endpoints real fast. So let's write get by ID. Oh wait, this isn't gonna work. Haha, let's run this. Boom, 500 server error. What's up? Reviews.get is not a function. Does anyone know why it isn't a function? Because you all are gonna do this. Oh, come on. Someone's got to see it.
You're not exporting the get function.
Exactly. I declared the get function, but I did not export it. So I need to include it within my module.exports object. And now, there we go. That works perfectly. So now I'm going to write my get by ID. And so we're going to return our reviews database, but I want to perform a where on it, and I want to check and see where the ID is equal to some value. Now there's a couple ways of structuring this, right? We expect this function to receive an ID as an argument, and we could say where in a string the column name, and then as the second argument the value. We can also pass it an object where the key name is going to be the column name, and then the value of that key is going to be the value of that column. I prefer that method. We can also exploit our object construction, I don't know, the reverse destructuring style, where I can just put the variable name of ID in here, and that will expand it to a key named ID with a value of the variable ID. And then, to avoid having to do any of the weird array destructuring or length checking or whatever, I can put my dot first on there. And so now, I can go down here. I'm actually just going to copy and paste this, because why not? So I'm going to get the colon ID here. I'm going to destructure the ID from my rec.params, and then I'm going to call get by ID. Give it the ID. Then we'll return the single review. We'll check and see if the review exists. If it does, they get the nice thing. If it doesn't, they get a 404. And review with ID does not exist. Error fetching review. Boom. You've probably written this a handful of times by now, so this should start to be feeling familiar. Up, did the same thing, forgot to export our function. See, it's gonna happen. It's good to be familiar with these error messages, right? Because then in the future when you see them, it's an easy fix. So try and remember what the error message says. Figure out what it means rather than just debugging your code immediately, right? It's telling me it's not a function. Why is it not a function? Because I didn't import it, right? So next time you see that error, you know what caused it. So here we go. Got our book. We can check a book that doesn't exist. Oh, I guess that one. Oh, our reviews. That's right. These are reviews, not books. So yeah, review 200 doesn't exist. Okay. So that's good. We're starting to go over time here. So before I write the other ones, real fast, I want to get to this this stretch here, because this is one of the reasons why developers like Knex, is because Knex is a query builder. So notice we're writing dynamic JavaScript functions here that take arguments and return things. So what Knex does is at runtime, when we invoke this function, it's going to use the stuff we've done here, all the methods we've called, to build up dynamically some raw SQL that it is then going to send to our database. So we can use Knex to build queries dynamically using the JavaScript tools that we already know. Whereas trying to write dynamic SQL within SQL is that's not something that we really want to do here. Instead, we can just use JavaScript. So I'm going to modify my get function here. And the idea is I want to be able to add query parameters to my request. I want to be able to do something like, when I get the reviews, put a question mark here to indicate that I'm providing query params. And then I am going to say, for example, limit is equal to, oh, I hate it when it autocompletes. Limit is equal to 1. And I want that to only return 1 review, or maybe 5 reviews. All right? And we can absolutely do that. First, Express does the hard part for us. In our request object, we can console log request.query. And we can see, if I pull up the terminal, we can see that it parses that into a nice object for us. Key called limit, value of 5. If I want to add more, I separate them by ampersands. And so we can add another one called sort by, and we can call this rating. And now we see that gets parsed out for us too. Oh, beautiful. Beautiful. Okay. So now I'm faced with the issue of how to handle this within my get function. So the way I'm going to do it is I'm going to have get expect an argument called options. And this is going to contain an object full of stuff that we might optionally want to apply to our query. And what I'm going to do is I'm going to have my get function do some destructuring from the query. So I want to get the limit, the sort by, and the sort direction. And these are going to come out of rec.query. And again, I like this destructuring style rather than just using this whole object, just so I discard anything that I'm not interested in processing. You don't have to do that. That's just what I like to do. And I am going to pass these as my options object into get. So limit, sort by, and sort direction. And now we can console log the options within here. It's important to console log as we're experimenting and trying new things to see how stuff reacts. So we see that inside of our get function, we have our limit coming through, the sort by coming through, and then the sort direction is undefined, right? We tried to destructure sortdir from the query, but it doesn't exist, so we get undefined. And now I want to handle these in order to build up my query, because we can treat our query like any other JavaScript variable. What I can do, I want to leave that there, is I'm actually going to create a variable, a let variable, it's mutable, and I'm going to set it equal to my DB reviews. And then I'm going to change it based on the values within options here. So if options.limit exists, then what I want to do is I want to modify my query. And I want to add to the end of the query limit. And I want to set its value to options.limit. Now, we have to be a little bit careful because whenever we're doing things through our URL, right, notice that limit is a string. Our URL is a string. The fact that we have numbers within the string does not make it a number. If we want to turn it into a number, that is something that you can Google, and there's lots of ways to do it. I'm going to use parse int, which takes the string that we want to parse as the first argument, and then the base of the number we want to translate it into. A lot of people feel like they can leave out the base. You can. It will work correctly a lot of the times, up until your number starts with 0, and then weird things will happen. So I want to specify I want a base 10 number. And then instead of returning this, I want to return the query that I've built up. So now let's see what happens if I set this limit equal to 1. We get 1 review back because we can dynamically build up this query here, right? And I'm going to prefer to use destructuring here because that is what makes me happy. So I'm going to destructure limit, and then I'm going to use that. And then I'm also going to destructure sort by and sortdir. And we can handle these two. So if sort by exists, then I want to modify my query. I want to set equal to query dot order by, right? That's our SQL command that we would use. That's the clause we would use in order to cause ordering to happen. And this is going to take as the first argument the column that we want to perform our ordering by. So this is going to be that value of the sort by variable. And then it also takes as the second argument the direction we want to perform our sorting in. That's either going to be ascending or descending. What we can do is we can give it the sortdir. But if the sortdir isn't defined, we can specify some optional some default value, that we want to use as the sort direction. So by default, let's sort by descending. Right, and this will work because if sortdir is not defined, then our OR operator is going to use this on the right-hand side. But if this is defined, if it's a truthy value, which is any string, then it's going to use that value. There's another way of doing this. We could set a default value on our destructure, which I'm going to do here because I'm not sure how many of you have seen that before. And what this is going to do is when it performs the destructuring, if it finds that sortdir is undefined, it will instead give it the value descending, which is pretty cool. So that's how I'm going to handle that. And now let's limit this at 5 let's do a sort by, and let's have it sort by the rating column, and let's have the sort direction be ascending. And there we go. We get our lowest rating, and we get exactly 5 of them. It's pretty neat, right? That's pretty neat. Come on. Come on, right? Dynamically making these queries. Oh, that's so cool. Look at how little code it is, too. Very small amount of code, and we've just created a very powerful endpoint. That's awesome. All right. Do we have questions about doing this?
Okay, so yeah, this is really cool. I have to give it to you. But the thing is, I'm confused. Like you're setting the query equal. You're querying the database. You're setting that equal to a variable.
Mm-hmm.
So when you say query.orderBy and query.limit, is that like I'm confused. Is that JavaScript or is that like, the Knex like SQL stuff?
So if I wanted to write this query where we always expected these things to appear, I could do db reviews, order by, and then give it the value of sort by and sort dir, and then I want to limit it with the parse int of limit of 10, and this is going to work just fine and dandy, right? This is just our Knex query builder using our methods in action, and this will work, right? The problem is what happens when I don't include some of these values. Like what happens if I do not include a limit here? Well, we can see what happens. Okay, so we get all of them, so it turns out this limit works correctly. Now, what if I don't include my sort by? Oh, here we go. Oh, and there's our error.message, right? Select star from reviews, order by undefined, SQLite error, no such column, undefined. Uh-oh. So we need some way to perform this optionally, right? We have this query builder here that we can chain methods on, and what this does is it builds a query. And what we can think of this as doing is whenever we add these methods, we're building up the SQL string, the actual command we're going to send to our database. And so whenever we add things to this query, we are adding to that string. And what Knex is going to do is it's going to build up that string to us, and then when we're done, it's going to send that off to the database. And that's when we put our .then. When we do our .then, we're saying, all right, no more string building. I want you to dispatch that off to the database, and I'm going to sit here and wait until we get a response back. So until we do a .then, we can keep adding stuff onto the end of this string, right? We're allowed to keep adding things to our command because we haven't sent it yet. And so we can do this using our JavaScript variables, right? We can think of this query initially starting as this string. Its value is going to be select star from reviews, right? This is what this next command directly translates into. And in the case that we have a sort by, I want to modify the query. And notice order by doesn't mutate. We're going to have to update the value of our query variable. And now this string is going to read as select star from reviews, order by whatever the value of sort by is, and in whatever direction sort dir is. Now, if we add the limit on here, because we've done this in the if statement, we don't know where this is actually starting from. What we're doing is really just adding on to the end of whatever query we already have, limit, and then the value of our limit, right? So we're building this query dynamically. And then I return it at the end of my function. And now what they're allowed to do with this request is put a .then on it, which Knex is going to go and ship that out to our database, and they're going to wait for the response. If we wanted to, we could actually keep chaining Knex things onto this. We're allowed to do that, right? Pretty weird, but we're allowed to do that. And in fact, something that I could do here is actually replace this db reviews with our get function, right? And keep chaining off of that, which it's pretty cool. So we build this query dynamically, which is going to create a string, and we can keep adding onto that until we perform our .then. At that point in time, we are waiting for the data to come back from the database after we have sent that string to the database to be interpreted. So, yeah, does that make more sense?
Absolutely, that makes a lot more sense.
All right, cool.
Thank you.
Cool. And this is really cool. These dynamic query builders let us do a really powerful mix of JavaScript and SQL. So, yeah. All right. Any other questions with this? Okay. So I'm going to write, let's write the post endpoint. I don't think I'm going to do put or delete just because we're starting to go over time pretty significantly here. So let's do post. So I'm going to do a router.post. And this is just going to be at our root endpoint. We're going to get the rec and res. And then normally what we would do here, right, is we wanted to structure the values we expect to see for this, which for our review is going to be rating, comment, user ID, and book ID. And we're going to structure that from rec.body. And then, right, we would do something like reviews.insert. I'm just going to write this without actually writing reviews.insert. I'm going to write my code top down. I'm going to assume that someone very kind, like Louise, has written reviews.insert for me, and I'm going to use it in the way that I find comfortable. And then I'm going to try to implement that function that makes everything work, right? This is kind of like writing a test. I'm writing what I expect the function to do before I write the function. This might be a good case to recognize, oh, this is test-driven development, right? I can actually write this as a test instead of just testing manually with Insomnia. And we're going to learn about back-end testing next week, and that's going to be cool. I'm a big fan of that as well. So what I would do is I would insert my reviews object, which is going to be my rating, my comment, my user ID, and my book ID. And then, you know what I would really like for this to do? I would like for it to give me back their review. I don't want to have to chain, another request in here to go and get it. I want my insert function to just give me back that review. That'd be very kind, right? So that's what I'm going to have happen. And then I'm going to do res.status 201. And then I'm going to send back the review as the JSON. Otherwise, going to catch this, going to get our error, and I'm going to copy and paste all of the good stuff that I had written previously. Error. Inserting review. Okay, now we have to go and write review.insert. Before I even write this function, I'm going to add it to the exports. Otherwise, I know I'm going to forget. Now let's write it. So insert is going to expect a review object. And what we're going to do is we're going to return our DB of reviews, and we're going to build up our query here. So here we're going to perform an insert, and we're going to give it the review object that we want to insert. Now the problem is, what this returns to us by default is an array that contains the ID of the row we had just inserted, right? It doesn't contain the review object, which is what I want inside of my router, right? I do not care about the database implementation of inserting. That is not my concern as the router developer. I just want to tell the database developer, who is also me, to just give me a function that inserts this review into the database and gives me back the new review, right? The router should be concerned with how that works. That's the whole point of a function, is that you get to abstract whatever that function does. So I am totally allowed to write my .then. Oop, where did I make that? Okay. I'm totally allowed to write my .then inside of here. I don't have to do that exclusively within my router. I'm allowed to write functions that aren't necessarily one-to-one mappings onto SQL queries, which is kind of what we did inside of our get, right? We mixed up some of our JavaScript and some of our SQL. Here we're going to do the same thing, but on the other side, right? So then what I'm going to do is I'm going to expect an ID inside of an array, and I'm going to grab that, and then I'm going to perform get by ID and give it that ID. And that's what I'm returning. I'm returning the operation of both inserting and then getting the value that was inserted into the database. Now notice I'm not going to write my .catch here. If this fails, I'm going to let it fail, and I'm going to leave that up to the endpoint developer to handle telling the user that it failed. There's some cases we might want a .catch on here. If this failed, there's ways in which we can build our query into a transaction, and if the transaction fails, we can roll that back, right? Like let's say we were inserting multiple things and one of those things failed, and if that fails, then the other things we inserted don't really make sense anymore. Then we can roll that back and then throw the error again for our endpoint developer to handle and tell the user that the request failed, but we're not going to get into that here. So this is how we write our nice functions. This is how we write our functions that take care of us. So let's test this out. Let's add a new request, new review. I'm going to make this a post request. We're going to hit up localhost 5000/reviews. We're going to give it a JSON body. And now we need the information of the rating, which should be a floating point number, which is a decimal number, and so we say it in computer speak. So I'm going to give it a 5. We're going to give it the book ID of book ID. We're going to give another review to Taylor. Our user ID, I'm going to do user 7, who I think exists and doesn't have a review. I set up this database to also yell at you if a user tries to review the same book twice, which is neat. And then what else do I need? Oh, I need a comment. The comment is actually optional, but ha 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 ha. Cover so funny. Good joke. There we go. So now I'm going to post this, and oop. We had a constraint fail. Look at how nice it is returning this message. Book ID, user ID, foreign key constraint failed. Maybe we don't have a user of 7. Oh, we didn't have a user of 7. So it was a user of 5 instead. And this is also something, right? You wouldn't supply this in a request. We'll learn again next week how to handle user authentication, and we would actually get that value out of that JSON web token. Pretty cool. Okay, so there we go. Now we have successfully posted our endpoint. We have written a nice insert function that also goes out and gets that data for us so that we can handle it very, very easily within our actual endpoint. So be kind to yourself. Write the right abstractions. Do we have any questions with this one? Okay. Does anyone have a burning desire to see the other endpoints put in delete? Because if not, then I'm going to call it here. Speak now. Forever hold your peace. Okay. Well, then that is going to wrap it up for me. Please let me know how you felt about the format of this video. If working through the other project was sufficient in clearing up any lingering questions or issues you had with the actual assigned project, you know, just let me know. Let me know what you felt. And I will see you tomorrow.